Welcome to multiple choice question 10 of the 2007 Mathematical Methods Exam 2. In this video we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. Now before we get into the problem, I'd just like to point out that the use of a CAS calculator is by far the most efficient way to answer this particular problem. And in fact you'll see if you hang around towards the end of this video that there's actually a really quick way of doing it on the calculator, as well as the initial by hand setup that I'll show you. For question 10 we have the graph of y equals kx subtract 3 intersects the graph of the parabola y equals x squared plus 8x at two distinct points for one of the following conditions for k. So the first thing that we can note here is that if we are talking about the number of points of intersection between a straight line and a parabola, then that can relate to the discriminant, and that if we want 2 points of intersection, then we want that discriminant to be greater than 0. So that's how we can ensure that there will be 2 points of intersection for this straight line and parabola. So now that we know that, we need to get this into a format where we can actually calculate the discriminant. So to do that, we're going to start by letting the two equations equal each other. So we're going to have x squared plus 8x, which is what y is equal to for the parabola. And we're going to set that equal to the kx minus 3, which is the rule of the straight line. So these two things being equal would find points of intersection between their graphs. Now this is a quadratic equation, so we like to solve these equal to 0. So we're going to subtract kx and add 3 to both sides of this equation. So therefore we end up with x squared plus 8x minus kx plus 3 is equal to 0. So we now have the quadratic equal to 0, but it's not yet in standard form where we can identify the coefficients of x squared, x, and the constant, or the values of a, b, and c. So we're going to do one more thing. So we're going to have x squared plus, and because there's two terms involving x, we're going to factor out the x, and we'd have 8 subtract k left behind. So 8 subtract k is the coefficient of x, and then we've still got plus 3 equals 0. So now we can go and calculate an expression for the discriminant, and we know the discriminant is equal to b squared minus 4 times a times c, where b, a, and c are the coefficients in that standard form. So therefore, b squared is going to be 8 subtract k squared minus 4 lots of a, which is the coefficient of x squared, which is just 1, times c, which is the constant term, which is 3. And to get those 2 points of intersection, we said that we needed to solve that greater than 0. And this is now something that our calculator can do for us. On the CAS calculator, go into the main menu. Next, we want to type in the inequality that we want to solve. So we want bracket 8 subtract k, so we can go keyboard, variable, and we can select k from in there. We want that squared minus 4 times 1 times 3, and we want that to be greater than 0. So under Math 3, we can use the inequality symbols to select greater than 0. And then we want to solve that for k. So we can go interactive, equation inequality, solve, but instead of solving for x, we solve for the variable k, and we can hit OK. So from the calculator, we can see the solutions to this inequation, where k is less than negative 2 root 3 plus 8, as well as k being greater than positive 2 root 3 plus 8. And now inspecting the options available to us, that means that B is the correct answer for this question. Now before we wrap up there, I just want to show you another way that you could have done that on the calculator, and it's a different approach, but some of you may really like it. So instead of finding an expression for the discriminant and solving it greater than 0 like we just showed, what we can actually do is type in the equation, which was x squared plus 8x equals, and then variable kx subtract 3. So that's the parabola equaling the straight line. And we can just solve this for x. So we go interactive, equation inequality, solve, and this time we will solve for x. And it will give us these two options that are essentially, if you look at them, a little bit like the general quadratic formula. And we know the bit under the square root sign is the discriminant. So if I drag down this expression under the square root sign, which involves k, and then solve that greater than 0 using the inequality symbol in Math 3, and we solve that for k, interactive equation equality solve for k, we'll actually get the same answers out. So it's just another way of tackling that problem where the calculator actually finds the discriminant for you. So even though there's not a command for finding the discriminant, by solving that equation for x, the bit under the square root sign ended up being the discriminant anyway, which we can then solve greater than 0 and get the same answers out. And finally, from the examiner's report, we can see that this question did challenge students on this exam, with only a touch over 50% of students getting this question correct. The examiner's report also goes on to show a similar method to the one that we took on the previous slide, and that is recognizing that two distinct solutions occur when the discriminant is greater than 0. So that's a really important thing for you to know and understand when you tackle questions like this.